YouTube channel. So let's continue with the intermolecular forces. So in this part, okay, we are going to discuss about what is hydrogen bond. So guys, these are the types of intermolecular forces. In this part, we are going to discuss about the hydrogen bonds. So what is hydrogen bond? It is actually a special dipole-dipole interaction between hydrogen atom in a polar of the NH, OH or FH bond and an electronegative of O, nitrogen, oxygen, nitrogen and fluorine atom. Okay, so when you see word of dipole, it means that it is actually where we have charge. Alright, okay, so here in order to have the hydrogen bond, you need to have the interaction between hydrogen with an electronegative atom. Okay, they are oxygen, nitrogen and also fluorine. Okay, so these are the hydrogen, the examples for the hydrogen bonds. Okay, we have different dipole moment and different charge here, where the hydrogen will hydrogen has the delta positive here, while the fluorine, oxygen and also nitrogen, they are very electronegative atom, so they are having the delta negative. So the high of difference in electronegativity of the NH, the OH and also the H and also F bonds cause these to be strong forces. Okay, it is about 5 times stronger than the normal dipole-dipole forces. Okay, so we need to have two essential requirements for the formation of a hydrogen bond. First thing is, okay, you need to have one molecule that must contain at least one hydrogen atom, okay, attached to a highly electronegative atom. Okay, so the fluorine, oxygen and also nitrogen. And the second one is, okay, the other molecule must contain fluorine, oxygen or nitrogen atoms that provides the lone pair of electrons. So here, okay, if we look at this diagram, why is the hydrogen bond considered as a special dipole-dipole interaction? Okay, here in this diagram, it has a boiling point and also the period for the periodic table. We have period 2, 3, 4 and also 5 here. But okay, all of these are polar compound, but what make them, or what make all these 4 periods different, okay, between each other, especially for the period 2 where they have highest boiling point, okay, compared to others, okay, because of the boiling point will increase as the molecular size increase. But other than that, okay, all these, especially for the H2O water, the hydrofluoric acid or HF, hydrogen fluoride, and also ammonia here and H3, okay, they have abnormally high boiling point. Okay, why? Alright, because usually we have a strong dipole-dipole forces, which what we call hydrogen bond. Okay, if we compare to other compounds. So let's try this. Okay, we have ammonia with a relative molecular mass of 17, while the boiling point is negative 33.3. Hydrogen fluoride, molecular mass is 20, boiling point is 19.5, while for the H2O water here, relative molecular mass is 18, but the boiling point is 100 degrees Celsius. So why? Why this happen? Okay, so the H2O or water here is much more or having much more higher boiling point than the hydrogen fluoride. Okay, if we have here we have nitrogen, fluorine and oxygen, but in terms of electronegativity, fluorine is the most electronegative atom compared to the oxygen. Okay, but why the boiling point of the water here is the highest? Okay, it is because of the hydrogen. Okay, in the H2O we have 2 hydrogen here. Okay, and then other than that we have 2 lone pairs, okay, at the oxygen. Okay, so this H2O can form the hydrogen bonds more extensively compared to the hydrogen fluoride and also ammonia. Okay, alright, so here, okay, let's go to the first one, ammonia. This is example of the hydrogen bond, okay, that form, okay, between these 3 molecules of ammonia. Okay, so each of these ammonia has only 1 lone pair. Okay, 1 lone pair, alright, at the central atom here, nitrogen, and on the average, each ammonia molecule can form only 1 hydrogen bond. Okay, why? It depends on the number of the lone pair itself. Okay, right. And then second one, we have here hydrogen fluoride. Okay, in this hydrogen fluoride, we only have 1 hydrogen atom if we compare it to the ammonia, and also 1 lone pair. Okay, alright, so here alright, so on the average here, each hydrogen fluoride molecule can also form only 1 hydrogen bond. Okay, and then the third one, okay, the H2O. So we have 2 lone pairs, okay, surrounding the central atom, oxygen. Okay, each water molecule here has 2 hydrogen atoms and 2 lone pairs. Okay, and then so on the average, okay, each H2O molecule can form 2 hydrogen bonds, okay, based on the number of lone pair. Okay, so we have 2 factors here. We need to refer to the lone pairs, number of lone pairs, and second one, number of hydrogen atom. Yes, alright. So here, this is the hydrogen bonding and also water here. The small size of hydrogen along with the shape and also the polarity of water molecule all add up to a relatively strong attraction between water molecules, and this hydrogen bonding is the strongest of the intermolecular forces. That's all for hydrogen bond. So don't forget to like, comment and subscribe to my YouTube channel. So I will see you guys in the next part. Bye!